So before we get into what a sex-linked trait pedigree looks like, I wanted to insert a little bitty joke. Yeah. Anyway, moving on. Okay, sex-linked here. So, what we see is that in every single case where the shape is completely filled in, it's a square, meaning that it is male, okay? And then the only time we see any shape that is half filled in, it's female, okay? Circular, all right? So this is a really good hint that it is a sex-linked trait, okay? So here again, it also makes note of the X versus the Y, not just the shape, all right? So the fact that 12 down here is not only a square, but it also has XY listed, it's kind of redundant because square means that it is male, but it's just kind of driving home that point, okay? Now the question is, let's look up here at 7 and 8. Okay, so the question is, what is 8's genotype? Okay, well, you've got your, let's draw this out here. Okay, so we have X doing the male, number 7 here. Okay, and we know that their kids, they can produce at least one female that is a carrier. Okay, so we know that this one has to be capital M. Okay, we know that at least one male does not have the disorder. Okay, now because you have two of these, it at least leans towards the idea that the mom here is actually homozygous dominant. Okay, and the fact that, well, granted they only had one son, but had they had another son, if he had also come out without the disorder, okay, it would have been even greater indication that the mother is most likely homozygous dominant. Not 100% sure, but most likely. Okay, so this is kind of where there's some uncertainty with pedigrees. Okay, so they don't necessarily want to call her a carrier, though she might be. Okay, but they do know that both of her daughters are definitely carriers because her husband had the disorder. Okay, so they inherited that little m from him. Okay, so, all right, so that's basically how you read a pedigree and how you look through it. Main thing is to remember squares are males, circles are females, fully filled in has the disorder, not filled in at all, it is either unknown or does not have the disorder, and then half shaded is a carrier. Okay? Alright, moving on to karyotype. So we've talked about these briefly before, but a karyotype is a picture of all the chromosomes in a cell. Right? So this is kind of an idealistic view of what it would look like. It's not ever like this clean and this certain. Okay? But basically, this is what a karyotype looks like. You have your 22 pairs of autosomal chromosomes, and then you have your sex chromosomes at the end. So karyotypes can actually show changes in chromosomes, if one is abnormally large or abnormally small, or if there is an extra of one type of chromosome. Okay? Deletion of a part of chromosome would be the chromosome is abnormally small. Loss of a whole chromosome, so if you have 45 chromosomes instead of 46, if you have, an addition to a chromosome, like an extra piece on there, if you have extra chromosomes, so you have 47 instead of 46, and duplications of parts of chromosomes. Okay? All right. So we're going to go through and try to identify what's different about this karyotype. Okay, so what do you see on this one? So it actually has 3 X chromosomes. So this is known as triple X syndrome. Okay, it is obviously female. Okay, there is no Y in there, at least that we know of. And this patient may have delayed development, so mental motor speech development, might be taller than average, though triple X syndrome is kind of a little weird because you can get that X inactivation going. So oftentimes triple X syndrome, it can be very detrimental, but it doesn't necessarily have to be. So it's a little bit strange. All right, what do you see in this one? Okay, so now there's only one X. So basically this genotype would be called XO, okay, because there is nothing for that second gene, or that second chromosome, okay? This one is called Turner syndrome, or Turner syndrome. It is missing a second sex chromosome, okay? Now because it's missing a Y, but it does have an X, this would be a female. It is, this person would be generally shorter than average, okay? Some developmental problems, especially with ovaries, okay? So you need the two X's to really develop the ovaries correctly, but otherwise, not a whole lot of difference, okay? And this really comes into the fact that you can survive quite easily with just one X. Ask any male, okay? So you can survive without a second sex chromosome. It just means that if this female has a recessive disorder on that X chromosome, it will be expressed. They don't have a second chance or a second shot at getting a dominant allele for that trait. All right, what do you see in this one? All right, we are still going on with these sex chromosomes. This is XYY syndrome. Great name, I know. Obviously, this one is going to be male, has two Ys, might be taller than average, increased risk of delayed development. So basically, there is too much information coming from both of those Ys, and the cells kind of get a little bit confused. So there is a risk of delayed development. Sorry, whoop, there we go. But because the Y chromosome doesn't have a whole lot of information, the cells can still survive. The person is still able to function quite well. I mean, there's not a whole lot of developmental issues that go along with this syndrome. Okay, a lot of people wouldn't even know that they have XYY syndrome, those that do have it. Okay, so, all right, what do you see here? You have an extra X. So this one is called Klinefelter syndrome. This is male, okay, because you have XXY, so you do still have that Y. So thought to be mostly undiagnosed, except in extreme cases. Might have delayed puberty, again, because you have those two X's. Some of the signals get a little bit weird, okay, with the hormones and all of that kind of stuff. But for the most part, because it is mostly undiagnosed, this one, hardly any side effects to having that extra chromosome. Nice thing about Klinefelter syndrome is that the males actually have less of a chance of having any sex-linked disorders. Okay, they also have the X inactivation in some places like a female would, okay, and they also have two shots at getting the dominant allele. So, not necessarily a bad thing to have two X's and a Y. Though, do have an increased risk for diseases such as breast cancer, osteoporosis, or lupus. Lupus, an autoimmune disorder. Okay? So, I mean, don't necessarily know, like the patients wouldn't necessarily know that they have this unless they had to go looking at their genome for some reason, and then they would find out. But do have that increased risk for breast cancer, osteoporosis, or lupus. All right, what do you see here? So you'll notice we are not talking about the sex chromosomes now. Instead, we are talking about chromosome 13. So this is called Patau syndrome. also known as trisomy 13. So tri meaning three copies of the chromosome 13. Patau syndrome is a lot more severe than any of the ones that we've looked at already. So severe intellectual disabilities and physical abnormalities. You get heart defects, brain or spinal cord abnormalities. So there's a lot that has to go into. Usually somebody born with Patau syndrome has a lot of surgeries early in life. And that's in an attempt to try to correct some of these defects. May die within the first days or weeks of life. So even if they do get those surgeries, they don't always work. Okay, so this is a case of there's just too much information for the cells. Okay, so only 5 to 10% of these patients live past the first year. So it's not a very good prognosis. Okay, somebody with trisomy 13. But what do you see in this one? Oh, well, okay, so I forgot to take off the third 13 chromosome, but now we have 318 chromosomes. So it's Edwards syndrome, or trisomy 18. This one, slow growth before birth, low birth weight because of that slow growth. Oftentimes we'll have heart defects or abnormalities in other organs. Severe developmental problems can be present. And then many die before birth or within the first month. So yet again, too much information, cells can't really function all that well with this. Okay. And as anything, there are different levels of severity that go along with each of these diseases. Some of them, when fertilization happens, if you have a trisomy in some of these, it's so severe at that point that the fertilized egg cell doesn't actually survive to become a zygote at all. Okay, so the person wouldn't even know that they were pregnant before their body said, that's not going to work. Or the fertilized egg cell said, I'm not going to work. Okay. Now, as you get smaller and smaller in the chromosomes, getting an extra copy is not as detrimental to the cells and the organism. So, again, 5 to 10% live past the first year with Edwards syndrome. All right, so what do you see in this one? We have 3 chromosome 21s. This is known as Down syndrome. It is trisomy 21. Okay, so this is probably one of the more frequently known of these trisomy syndromes. Okay, varying levels of cognitive delay. There are some with Down syndrome who don't seem to have hardly any cognitive delay. There are some that have quite a bit. So there is a very vast level of cognitive delay or defects there. Heart defects are very common with patients with Down syndrome. Digestive abnormalities. A lot of Down syndrome people have to be very careful about what they eat. They also have underactive thyroid glands are common, so they can gain weight really easily. So it's kind of a battle there. Celiac disease is actually kind of a different form of celiac disease that isn't necessarily linked to the dominant recessive trait that we talked about in one of the previous sections. So there's a lot that can go along with Down syndrome, but it's not necessarily saying that everyone who has Down syndrome is going to be, have heart defects, digestive abnormalities, all of that. Okay. You also get the very characteristic facial features. Okay, and I'm sure you all know what someone with Down syndrome looks like. So you get those very characteristic eye shapes, all of that. Okay. All right, that is the end of Chapter 8.